Now we are going to start the next chapter, that is a solid state. Now what do you mean by solid first of all? In solid state, what is a solid? Or you may say solid is a state of matter, like liquid and gas and plasma and that is BEC. We are having solid is another state of matter, correct? But still then I am asking you my same question, what is a solid? What do you understand with the term solid? Solid is defined as that, what you can say, form of matter which possess rigidity and hence possess a definite shape and a definite volume. Again I repeat, solid is that state of matter, is defined as that state of matter which possesses rigidity. As a result, it has got a definite shape and a definite volume. Now the thing is that is we come to know solids are rigid, they have got a definite shape and hence they have got a definite volume. They have large number of free surfaces, a solid has. We have studied all these things. Now what leads to this particular factors? This factor which I said, it has got definite shape, definite volume, it is rigid, it has got large number of free surfaces, it is having high density. What leads to these particular factors? Two things are there. One is the strong intermolecular forces between the atoms or the molecules or the ions in the solid. That means between the constituent particles of the solid. We can say that. Whether it is atoms, whether it is ions, whether it is molecules. Because solids are of different types, we will study now. Different types of solids are there. Molecular solid, ionic solid, network solid, covalent solid. We will be studying it now. So based upon that, we can say that the constituent particles have got strong intermolecular force of attraction between them. Point number one. And secondly, the thermal energy which decides the stability of a particular substance is very, very low. The thermal energy is in the lowest state and the intermolecular force of attraction is the maximum. When these two factors are coming closer in a particular substance, then the substance possesses these properties. What is that? It is rigid, it is having high density, it is having a definite shape, it is having a definite volume, it is having large number of free surfaces and so on, which you have studied in the lower classes about the type of solid. Alright, remember it. What is that I said? The two things or the two factors which is responsible for the characteristics of the solid is that one is the intermolecular force of attraction is very, very strong, very, very strong, whatever the solid it is, whether it is ionic solid or molecular solids or polar solids or hydrogen bonded solids or covalent solids, whatever the solids or the metallic solids, intermolecular force of attraction should be very strong. And secondly, so as to have the solid in the stable state, the thermal energy should be in the lowest state. Alright, these two factors you need to understand first. Now solids again is of two types. What is that? One is your crystalline solids, and another is your amorphous solid, amorphous. Now let me tell you one thing here, children, that is amorphous term is no more used nowadays. It is known as microcrystalline. That means the scientists are of the opinion that there is nothing which is in the powder state. Even the powder amorphous in the powder, isn't it? Even if a substance, if you observe it under a powerful microscope in the powder state, you will find there are minute particles. There are some nanoparticles are there in the crystalline state. The nanoparticles are being present. So hence nowadays we use a term that is microcrystalline. This particular one is known as microcrystalline state. Okay, amorphous state is also otherwise known as. Now we will see some differences between these solids. Now which solids are crystalline solids? All metals, we can say that, metals and the compounds in the ionic state, they are all is in the crystalline solids. Alright, all the solid elements, that is it can be metals, it can be non-metals, and the compounds in the ionic state, in the solid state, they are coming under what you can say crystalline solids. Now amorphous solids are nothing but a rubber, it is glass, it is pitch, we can say that, then tar, then fused silica, then plastics, then polythene, they are coming under amorphous solids, we can say that. Now if you see first the arrangement of the crystalline solids, arrangement of what? The constituent particles in crystalline solids. It follows a long range order. Whereas in amorphous solids, it follows a short range order. Means, what do you mean by long range order and short range order? Means, long range order means, if you look at the solid, like suppose this is solid. If you look from this side, what is that? It is circular. If you look from the other end, it is also circular. That means what you find is that by looking at any of the cross section, when you are seeing a crystalline solids, if you look at any of the cross section of the crystalline solid, you can judge what is the shape of that particular solid. I can judge it because that particular cross section remains the same throughout the solid. Am I able to make you understand? What is that I said? That is, if you see this particular solid, you can see here, it is circular. Got it? It is circular. Here also, this end also is circular. So, if you take the cross section of this solid, suppose I break it this one here, and what will I get? I will get a circular. Suppose I break it here, what will I get? I will get a circular. So, looking at the cross section at any point, you can judge, what you can say, the shape of the solid. That is called as long range order. That means the order means arrangement of the solid is same throughout. That means if it is so what you can say cylindrical, it is same throughout. The cross section is being same throughout. Alright, the arrangement of this solid is being same throughout. So that is called as long range order. If it is cubical, it will be cubical throughout. If it is cuboidal, it will be cuboidal throughout. So if you break that particular solid in any cross section, you will find that the shape is the same throughout. That is called as long range order. We can say that long range order. Clear? Fine. Now next is, after that we will come to the short range order. Short range order, amorphous solids are short range order. Means up to a certain extent you will find it is cubical, then you will find it is cuboidal, then you will find it is cylindrical. Alright, in this way the shape will not be the same throughout. It will be different. Alright, it will be different in different cross section, you will be finding it out. That is called as short range order. So amorphous solids are short range order because the shape is not the same throughout. Suppose you will get it crystalline, cubical, then after what you can say certain distance, after certain length, after certain cross section, you will find it cuboidal. After certain cross section, you will find it again it is circular or it is rhombical, not it, or it is quadrilateral in this way. So the shape you will be differing, we can say that. The cross section will be differing, so that is called as amorphous solids, we can say that. Next, if you cut a crystalline solid, it gives a sharp cleavage. Yes, if you cut it, suppose an iron plate, if you cut it, you will see it's a sharp cleavage. It is so sharp that it shines. When the light falls upon it, what happens? It shines. Or it gives a sharp cleavage. But an amorphous solid gives a blunt cleavage. When you cut it, when you break it, it does not break uniformly. It breaks in an uneven manner. Alright, it breaks in an uneven manner. For example, glass. Glass is coming under amorphous solids only. Alright, when the glass breaks, does it break in a even manner? No, uneven. You will be finding out this sort of, you will be finding out. Alright, this sort of uneven manner it is. Clear? Okay, so in this way, what you find is that it has not got sharp cleavage, it has got a blunt cleavage. We can say that. When a crystalline solid is being cut, when the light falls upon it, alright, what happens is that it reflects the light because it is bright, it is having a luster. But amorphous solid does not have that luster. It does not have that particular luster, except few, we can say that. Graphite, iodine and all those things. That is graphite, we can say that. Clear? In this way. Now, next is, what you find is that crystalline solids, due to this particular reason, they have got a high melting point or a sharp melting point. You will find it out. But amorphous solid, they have got a range of melting point. Now, I can give you an example. You have read in organic chemistry that temperature ranges from 525 to 575 Kelvin. For example, ethene plus hydrogen in presence of 525 to 575 Kelvin gives, what is that? Nothing but ethane gas. Ethyl alcohol in presence of conc H2SO for 140 to 160 degrees Celsius. So what you find is that amorphous solids, when they react or when they are heated or when they are boiled, alright, they do not have a sharp melting point or sharp boiling point. What they have? They have got a range of boiling point, range of melting point, we can say that, due to this particular reason. Because their constituent particles are not the same throughout. Their arrangement is not the same throughout. The cross section is not the same throughout. So for that particular purpose, it has got a range of melting point. Clear? Now, next is, what you find is that crystalline solids, they are anisotropic in nature. Alright, anisotropic, so to say. Anisotropic in nature, crystalline solids, and this is isotropic in nature. What do you mean by anisotropic? Anisotropic means, that is, what you find is that the properties like electrical conductivity, thermal conductivity, refractive index. Got it? These are the physical properties, what I am saying. So what do you find? That this particular properties, what it, physical as well as chemical is there. So you find that these properties is different in different directions. Why? Because the arrangement of the molecules in crystalline solid is different in different directions. But in case of amorphous solids, these properties, electrical conductivity, magnetic conductivity, thermal conductivity, refractive index, is the same in all the directions. Why? Because the arrangement of the solid is the same in all the directions. Okay, now let us see it. First, let us come to the crystalline solids, the arrangement. Let us take sodium chloride, Na plus Cl minus. Again, Na plus Cl minus. Cl minus, Na plus, again Cl minus, Na plus, again I am taking Na plus, then Cl minus, again that is Na plus, Cl minus. In this way it is arranged. Alright, in this way it is arranged. So what you find is that, see, the what you can say, the if I take the diagonal, I need to have one more here. So let me write it here, a small one, let me write it here. That is Cl minus, then it is Na plus, then it is Cl minus, then it is Na plus, because it is what you find is that same throughout. Clear? So here what you find is that is C, the arrangement in diagonally, Cl minus, Cl minus, Cl minus. You see the arrangement here, Na plus, Cl minus, Na plus, Cl minus, and this way. You see the arrangement in this diagonal, what is that? Na plus, Na plus, Na plus. So the arrangement is different in different directions. So the properties is also different in different directions. So hence it is called as anisotropic in nature. Understood now? So crystalline solids are anisotropic because you see the arrangement here, you see the arrangement here, you see the arrangement here. It is different in different directions, due to which the properties are also different in different directions, which is called as anisotropic. But in isotropic, it is same throughout. How? For example, let us take oxygen. It will be O2, 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 same throughout. Alright? It will be same throughout, we can say that. The arrangement is same in all the directions. In this way, what you find is that, now you may say oxygen is a gas. It's a gas, sir, it's not a solid. Yes, I know that. You condense it, cool it, you'll be getting a solid. For example, you can say that carbon dioxide, it forms what? Dry ice. How do you get carbon dioxide? It's a gas. You cool and solidify the, what you can say, gas. Then what happens? It solidifies to form dry ice. It's a solid. Alright, we can get the solid in this way. Of course, in the natural state, it is not available in the solids. But we can solidify it or not. Yes, that's it. That's what I am saying. Clear? In this way, there are certain differences between amorphous solids and crystalline solids. Similarly, amorphous solids are said to be as pseudo-solids. Pseudo means false. Alright, crystalline solids are known as true solids. Now why amorphous solids are pseudo-solids? Because even if it is solid, alright, it's not crystalline in nature, it flows. How can you say it flows? For example, glass. Alright, if you see the, what you can say, the window panes of the old buildings or the window panes of the old buses, you find that it is at the bottom it is thicker and the top it is thinner. You can move it in this way. Clear? And you will find the old buses or in the old buildings of window panes, it has been stuck somewhere in the middle. Suppose you have opened the glass and you have opened it and it is being stuck somewhere in the middle. Then it does not move. Similarly, suppose if you are having a showcase in your house, let us say a glass is there, showcase. You understand what is a showcase? When you have brought the showcase, you find that the glass panes are moving very freely. But after a few years, you find it does not move freely. Why? Because the base becomes thicker. How it becomes thicker? Because due to temperature and pressure and also due to gravity, the glass molecule flows from higher level to the lower level, which is known as annealing. The process is called as. The annihilation takes place year after year. Temperature, pressure and gravity, the glass molecule flows, and due to which the base becomes thicker and the top becomes thinner. If you are having an what you can say, the old this sort of what is that, showcase, you can see it. The top is what you can say, thinner. It is moving in this way, but the base becomes thicker. It does not move, so it does not move freely. But when you have brought it, when you purchase it new, then it is very fine. It is moving freely, moving. The panes, we can say the glass panes. Why? Because the same thing. Similarly, you can see the old window panes. It appears milky. The glass appears milky. Alright, even the specks, after a few years, if you are having an old specks, you find that somewhere some spots is appearing. So what you do is that you just take out the specks and you rub it. You rub it. You see some, what you can say, some spots you see and you rub it. But that spots you cannot remove it by rubbing because internal arrangement has changed. The internal arrangement has changed. Of course, nowadays the specs are available, the glasses are available, which does not change the internal arrangement. So many glasses. I'm not going to those particular one. But the ordinary glasses I'm talking to you, the ordinary glasses, you'll find that is the internal arrangement changes. For that purpose, you'll find somewhere it is milky, it is hazy, it does not appear clear to you, it appears translucent, it's not transparent. Why? Same reason. Due to temperature, pressure and due to gravity, the glass molecule flows. I am talking about ordinary glass, mind it here. It flows, and due to this particular reason, the molecular arrangement changes, and hence it appears somewhere milky, somewhere transparent clearly. That's the reason. So these are the difference between amorphous solids and crystalline solids, so to say. Thank you.